So today I thought I'd show my radius turner, or some people call it a ball turner. Half the time I call it ball turner, the other half I call it a radius turner. I built this years ago when I had my Atlas lathe, and I've since retrofitted it for my Grizzly lathe. I'm going to take this apart and kind of show. I didn't document the build, but I'll take it apart, show you how it was for the Atlas lathe and what I did to modify it to fit this Grizzly. I was going to build an entire new one just for the Grizzly, and I figured I'd just modify this one to where it'd work. Yeah, let me get it taken apart, or let me get the things to take it apart, and we'll get started. Okay, so basically you've got the handle here. I'm not going to take that out. It's just threaded in. And then I actually turned this brass ball with this ball turner. And the way this thing works, I've got these Allens already loosened up. Let me get me some glasses so I can see what I'm doing. I haven't really got it calibrated, you know, on the money, but I've got some rough markings on it, as you can see right here. And on this side, and depending on if you can see that mark that I've got, I just scribed a line onto this piece here that's sliding, and whenever those two lines right there are lined up, the tip of that insert is on center. So whenever this thing rotates, that's not going to move. That's right on center. And then I can measure, you know, whatever kind of radius I want. I can measure from there and push it back, or even pull it forward if I want to do a concave. So the reason this is shaped like this, with a cutter on both sides, is so that I can flip this around and depending on how much stick out, I can do a concave cut. So if there was a piece of stock here, it would actually have a concave cut in it. Pull it way in, it'd be just a real tight concave cut. And yeah, I'll even do that on a piece of stock. I'll show you turning a ball in, and then I'll do a couple concave cuts. But whenever I made this, I intentionally, you can see how I milled about a 10 or 20 thousandths groove in it. I don't know exactly how deep it is, but it's deep enough to where whenever the Allens, those little set screws, so got a slot in there, and you can see the set screws coming through. Whenever they tighten up on that, you know, of course it's going to get a little marred up, and you don't want your sliding surfaces to start being interfered with that. So I want this to be able to nicely slide to where I want it, and then tighten up these set screws to keep it in place. But then whenever you're ready for it to slide, it will still be able to slide, because it slides on the machine surfaces here and up here. So I think you probably get the point there. So we'll take this, so you can kind of see what I did here. And this was, like I say, this was years ago. My Atlas lathe was a 10-inch lathe. I was using a bunch of these little tiny inserts right here. I actually do plan on making another one of these for this base here with a different insert style. I don't know exactly what insert style I'm going to go with, but yeah, whenever I made this, these were the inserts that most of my stuff was, most of my cutters was using. And the only reason these are in there, these were for the Atlas. So let me take these out and I'll show you what I mean. I'm going to set the camera down. Take these out, or maybe just loosen them off to where I can get the top of it off. So the Atlas has a dovetail for the compound to rotate on, and then it's got two of these bolts here. There's concave, not concave, but whatever you want to call them, beveled, I guess would be a good word. Hold on just a second and I'll show you what I mean. You see that beveled stud coming out. So the way this would work on the Atlas is I would just take the compound off and set this right down on the Atlas, then tighten up the these screws here that would pull these in, and it would tighten it up on the dovetail of the Atlas lathe. So this would just set straight down on the carriage with the compound removed, and then it would swivel, like that, and it worked great. Then I got a bigger lathe. That's a 12 by 36 Grizzly. Had to figure out a way to make this work with it or build a whole new one. So what I did was I just made an adapter plate. Now this adapter plate bolts to the Grizzly and basically works the same way. This is a two-piece deal. I custom machined this screw, so whenever it's completely tightened up, there is no slop. You know what? Let me take that out so you can kind of see how this was machined. There's kind of an important feature that you probably want to know, and then you'll better see what the greaser is all about. Okay. Before I take that out, I'm going to go ahead and take these out. And these I just made out of regular bolts. Now if you make one of these, you don't need to worry about this. I would not have done this way with a dovetail base and all that if I didn't retrofit this over from an Atlas lathe. That's the custom bolt that's machined with a shoulder on it, so that whenever it's completely tight on that, there's virtually no slop. Now if you take a look at this, there's let me get some digital calipers. Okay, so if you take a look at this is actually the top piece. There's a little lip, as you can see, hopefully, that I machined in there. And then on this piece, it's got a mating lip, so that whenever it sets down on there, it just fits right down in there, does not have any side-to-side movement, and it's just butter smooth whenever it rotates. So what I thought I would do is put a greaser in there. I've got a hole drilled there, so I've got a hole drilled in sideways, and then a hole drilled down to intersect that hole. So when I pump grease in here, it fills this little cavity up with grease, and whenever this is all together, I'll get just a little bit of squeeze out in between the seam here, and this thing just glides like it's on a bearing, and it works really good. So I don't know if hopefully you can kind of see what I'm talking about there. And how it fits right down in there just the way it's supposed to. so let me get this thing back together. None of these dimensions are critical. I mean, I didn't draw up any plans or anything for any of this. I just simply thought it up and started machining and just made everything fit on the go. You could draw up plans and probably get it done even quicker than what I did, because a lot of times when you do it just off the top of your head, you run into things that you didn't really think about, and you have to overcome that stuff. So yeah, let me get this back together. I will get it over here on the machine, and I'll show you how it works. Okay, got my compound removed. Just want to come in here. The bolts there. Line right up with these. So I'll put those nuts on, and I'll snug these nuts down here, and then that'll be mounted up, and I'll come back and we'll turn a ball on that, and then a concave radius. Okay, so what I did, this is 1-inch bar aluminum. I lined my scribe line up with the line here on the base, and all I did is I took some calipers and I measured from this line to this line, 1/2 inch. That's going to get me really close to what I need. It takes a little bit of time to dial it in if you need to be exactly right on the money. I mean, anything I've ever turned with this, I've never had to be that precise with it. So this right here, that's a 1/2 inch radius. So for a 1-inch bar, that should be what we want. So I've got it all mounted up. I've got it centered. So I'm going to mount the camera up here on the Noga base, and we'll get started with this. And hopefully you guys will have a good enough view. So basically, I'm going to work the cross feed, cross slide, and the carriage to get my radius. Let's see, we'll bump this up to C2. All right. Okay, let's see what we can do. All right, so Got a nice round end on that bar. This insert isn't exactly on center. You can see the little teat right there. Usually what I do is I just take a file that off, and then if I need to polish that out, I'll polish it out. If not, I just leave it alone. But and then if you have a, like whenever I turn this, what I did is I just mounted this on this bar, the arm, mounted the arm in there, turned this, and then screwed this back in. Did the little angle right there, and then screwed that back in. You can actually, as long as the bar is not the same diameter as the radius that you're wanting right here, you mount, you know, a piece of, you know, whatever you're wanting to turn around. If you're wanting a round ball, and I thought I had some around here somewhere. Yeah, this is a perfect example. So I turned this on that. So you can see how, you know, I mean, I did a full radius right here until it got down into this area. I just mounted this. This was a solid piece of bar, about 1 inch long. Threaded it, screwed it onto the handle. This is, by the way, the quick change tool post. I just mounted, you know, this arm in the chuck. That way it allowed me to keep going around to turn a you know, a round ball. Instead of having to, you know, stop right there, you can keep going as long as you've got the, you know, as long as you got the clearance to keep turning this around like that. You can keep going around to get a you know, a full circle. But right now I can't, because the, you know, the rod is the same size. If I keep going, yeah, it'll cut into it, but it's only going to cut in so deep before it's just taking too much material away, and it'll start shattering. Hopefully you get what I'm trying to say. But all in all, very nice setup. Now, let me show you the concave part of the way this works. Get this out of the way. Where's my, let me find my Allen. Here it is. And again, depending on how much of a concave, I have no idea what kind of radius that is, but we're just going to leave it right there. Like I say, you can pull it in to get it real tight. In fact, we'll do a couple of them. I'll pull it in about, that looks like about 1/4. And I'm just going to hold the camera this time. There's a concave. Leaves a nice, beautiful finish. Then if you want it even more, When you start getting close to the chuck, just make sure that you're not going to hit. That should be good. Okay. Anyway, hopefully you get the idea. So you can turn radiuses and concave. I guess those are still concave radiuses. Concave, convex radiuses, I guess is the proper term. Works good. Don't use it a whole lot, but when I do, it's nice to have. And if you was to build one, like I say, you wouldn't have to do a retrofit deal like this. You wouldn't have to have these two bolts. Just turn you down, you know, a piece of stock that'll fit right down on here, and find your center height, and you know, all that good stuff. But all in all, that's pretty much it. That's just my homemade ball turner. I've had people over the years ask about it, and I never documented it whenever I built it or nothing. So you know, I didn't know people would be curious about it. And like I say, if I had to do it over again, I'd totally do different inserts. I was actually thinking, I forget what insert that is, but I was thinking maybe an insert like that. But I don't know. I don't know what the best insert would be for it. But anyway, I'm out.